Hi guys, this is Mr. Gagnon again, and I am going to be taking a peek at this problem that we had here, and we solved for the resultant vector using the graphical method. Now, okay, what we're going to do is we're going to take and try to find this answer with the component method. Okay, so let me use the same paper here so that way we can not only not waste paper but also compare our resultants later. So here is my section that I'm going to be using to find the answer using the component method. Now, when I think of components, I think of pieces or parts. I can think back to my old stereo system when I was a kid. I had components to that system. I had the FM radio. I had the turntable. Yes, believe it or not, I had a turntable. I had a tape player component. I had a CD player component. Those are all components to the full system. So when we look visually at this vector, okay, it has an x component and also has a y component. This vector has an x component and a y component. This vector has an x component and a y component. So because they have components in the x and y directions, we can get rid of these silly angles and just use like right angles. It becomes more simple. Okay, so we'll get into it right now and I'll show you how to do it. So in this situation, we're going to have to come up with a chart here. So we will call the chart x components and y components. Now, this one's simple because it's north, it's positive, it's all y. The x component of this is not going to be anything. So let's take a peek. All right. Now, earlier I said we're going to relate all of the angles to the x-axis, and here's the reason why. Okay, so let's look at how much y we have and how much x we have in this first one. So 6 centimeters north, there's no x in this first one. There's no x, it's all y. Okay, there's our first one. We broke it up into its x and y components. Now the second one, we can actually label this if we wanted to. A, B, and C, and R. Okay, the second one we're looking at, I'll draw a line here. Second vector has a bit of x and a bit of y. It actually has, if we were to measure it, okay, we were to measure this, okay, we could find out exactly how much x and y it has. So this one has some x, and this one has some y to it. Okay, so to get the x part of it, assuming we're on the x-axis, we can use the cosine. So here we go. 2 cosine 45 degrees. 2 sine 45 degrees. Okay, will be the y part. Because in the y we're using the sine function, for the x we're using the cosine function. So if I solve for this, okay, and you can do that with a calculator, or if you know your sine cosines, this ends up being 1.41. This ends up being the same thing, I think, 1.41. In the positive direction, they're in that quadrant which says that the x and the y are both positive. So we got positive and positive. Okay, so I've resolved that vector into its x and to its y components. Now I'm going to resolve this one here into its x and y, and just by looking at it, if I draw a dotted line for the x is the negative direction, and I know that by looking at that. The y, okay, here's the x and here's the y. The y is going to be in the positive direction. Okay, so I'm going to break apart this last one very simply. 5 cosine 25 degrees, 5 sine 25 degrees. Okay, and I don't remember what those were, so I am going to get that for you now. Now keep in mind that because this is a negative direction in this quadrant, that the x is going to be negative and the y will be positive. So we have our numbers here. Now, here's the part where we can compare this resultant vector. Okay, we can compare this resultant vector to the new one that we get with the component method. So all I'm going to do, right, I'm going to strike through here. I'm going to strike through here because we're looking at just the numbers here. So let's add up all of the x's. Okay, that would be this one plus this one. Now it turns out that this one is 1.4 this way. This one is a negative 4.5. So let's check out what we've got. Okay, got negative 3.1 centimeters on one side. That represents all of the x's. And the y side, I've got 6 plus 2.1. Okay, so here is what I've got for my x total and my y total. So we'll see what that looks like here. So let's add up the vectors. Okay, and what that's going to look like is a negative 3.1. So I'm going to take and actually measure it out just to show you guys that if I were to actually draw this out, that my x vector would be negative 3.1, and then the y would go up from that. So I am going to strike through that and do another one down here because I realized my space is limited. So we're going to draw our first vector, negative 3.1, the x's, and then we're going to add in this one to the head of that one. So we're going to go 9. I'm sorry about that strike through. It shouldn't let us. So 9.51 brings us to about here. Okay, so here is the 9.51. Again, ignore this little piece here. This is my negative 3.1. Those are the x's and the y's that we came up with. Now, we start here for our resultant, and we are going to draw a line from here to here. Now, I just wanted to point this out to you guys. Okay, this is super important. Now, normally you don't have to draw this triangle like perfectly. You don't even have to get it to measure anything here, but I wanted to measure it just to show you that we have a vector that's headed in this direction. And look at this one looks very similar to this one, doesn't it? Okay, because we found all the y's and x's. Now this would be hard to do if we didn't separate it into its components. Now if I take this and I don't measure it, and I do a little Pythagorean theorem to it, okay, and I take 9.51 squared plus the square root. So this, if I solve it algebraically, comes out to 10.0 centimeters. And I can also get this angle, okay, without measuring it, but using a little bit of trig. So let's see how close we came. Well, we came pretty close with this because I got 10.0 centimeters. If we compare the two, we got 10.0 and 10.5. Now, if I solve for this angle, okay, I can do that. Okay, I'm going to take and solve for this angle, and I can use any trig function I want. Opposite over adjacent is fine. So opposite over adjacent. Okay. No, okay, so 9.51. Okay. Now notice, after solving for this, I got 71.9 degrees. And if I look at this as a coordinate plane, this is north of west. So my answer was 10 centimeters, 71.9 degrees north of west. Okay, now I got 10.5 at 70 degrees north of west using the graphical method. Using the component method, I got 10 centimeters at 71.9 degrees. Now this shows you graphically what we're doing, but this is more accurate. So the component method is more accurate than the graphical method. Okay? And we'll do a few of these in class and you'll get the idea. But I just wanted to really point out that look at this resultant. It looks strikingly resemble to each other. All right, so they resemble each other. Look at that. They look nearly exactly the same. If I were to take and measure this one, I could find that it's about 10. This one, it's about 10.5 or so. Okay, that's that, and we'll talk to you soon.